Okay then, so we're going to start looking at network topologies, and this is the way that networks are logically laid out. There are four you need to be aware of. The first one, and this is one that's not used much anymore, is the bus network. And we have a straight line, our backbone, and we have a terminator on each end. And then off of this, we have a connection for each computer. Now, this is an old topology, an old logical design. Let's have another computer in there as well. And the problem with this is that all our bandwidth is all being shared. So the amount of people using the network are going to slow down the network. And also if we get a problem, somebody damages that cable there, for example, the whole network goes down. So that is our bus topology. It looks a little bit like a bus timetable. If we then split this up and look at the next one. The next one is called a ring topology. And as you can guess, that is very much in a ring shape. So we've got our computers. I have one more in here. And they're connected with a cable that goes right round. Again, very much an old kind of topology, an old network, old logical way of connecting things. And this works by sending the information round on a little token as it goes round, and it's known as token ring topology. The problem with this, again, is that if somebody switches off a computer or we break a cable, we lose the whole network. So these are our old logical topologies. We've moved away from that now, and now we look at networks that are much better in terms of resilience. They're much more reliable. We have a switch in the middle, which used to be a hub, but now is a switch. I know it's quite hard to see, but off of this switch, we then have some computers, which are also known as nodes. These computers each get sent information. Let's put another screen in there. Yeah, sent information from the switch, and the switch will distribute information out to each of those computers as and when it's needed. So instead of broadcasting, like we did here, we've got much better bandwidth because the connection is only used for each individual computer. Now, if we have a problem where this cable maybe gets broken, the rest of the network stays up. However, the only downside to this is if maybe the switch itself gets damaged or gets turned off, then the network will come down. The final network, and the most resilient network, in fact, I didn't tell you the name of this one. This one up here is called the star because every line comes out and it can create a star-like shape when we have more computers. The final one, which is down here, is going to be our mesh network. This is the most resilient network, and this is very much how the internet works, in terms of there are lots of connections that connect up lots of different devices, and they don't always go the same route. The problem with this is it becomes very expensive when we want to expand our network because we have to add in more cables. So, much like the ring network we talked about before, we're connecting all the devices together. However, each device has a cable to each other device, which eventually builds up a very mesh-like network. The downside, like I said, is if we add a sixth device, and this could be any device, we need to add more cables that connect us into each one of these computers. Again, if we add another device over here, we're again going to add loads more cables, making it very expensive. So the mesh system, a very expensive system, but very reliable system. We've got this star system, which is much more convenient. This is the system that we'd see in most of our schools and most of our homes, in terms of this device will connect out and hand out the information. The bus topology, which is an old one, which is not so reliable, can easily be damaged and quite slow because all the devices are talking across one cable. And the ring topology. Again, not used very much an old system, and very much the older topology that isn't used because it's not as reliable. Star topology is what you're going to see in most environments.